Hello, my name is Raphaël Pinson and I'm a technical marketing engineer at Isovalent. Today I want to tell you about new features related to Egress gateway in Isovalent Enterprise for Cilium 115. So Egress gateway is a feature of Cilium that allows to exit a Kubernetes cluster through a specific egress IP when coming from a specific workload identified by a selector and going through to an external CIDR that is identified by a subnet. This is extremely useful, especially if you have like a firewall outside of the cluster or maybe a database that is aware of the source IP and filters traffic based on that source IP. So it can associate the source IP to a specific workload coming from the Kubernetes cluster. Now, one problem with this is resiliency. In Isovalent Enterprise for Cilium, we already have a system for HA for egress gateway in Cilium, allowing to exit through multiple nodes and load balancing the egress traffic through these nodes. But what happens if you have multiple availability zones? It could be in a cloud or it could be even on-premise for your Kubernetes cluster, which is good practice. Is there a risk that your traffic coming from a workload running in one availability zone would be routed through an egress node in another availability zone, which would add latency to the traffic? In order to solve this, we've added a topology-aware egress routing option with an AZ affinity in Isovalent Enterprise for Cilium 115. How does it work? It is based on the well-known label topology.kubernetes.io/zone in Kubernetes. And so we're going to tag the nodes in the cluster. In our case, we'll just tag them. Usually the Kubernetes distribution does it already automatically by adding a label on the nodes for topology.kubernetes.io/zone. And in our case, we'll tag some nodes, both compute nodes and egress nodes, with the east zone and some other nodes with the west zone. So let's see what this looks like. We have an X-Wing workload. I'm going to zoom in a little bit. We have an X-Wing workload running in the cluster, and we're going to add labels to the nodes. So we'll label kind worker, which is a compute node, as east, as well as kind worker 3, which will be the corresponding egress node, as east. And same for the west zone for kind worker 2 and kind worker 4. So we've labeled these nodes, and if we look at the labels, you see here that we have kind worker labeled for east, kind worker 2 for west, 3 for east, and 4 for west. Now we're going to write a gateway policy, an egress gateway policy for HA. This is something already quite common in Isovalent Enterprise for Cilium, and we're just going to add the AZ affinity parameter with local only first, which will make it so that preferably the traffic coming from a workload in the Kubernetes cluster and exiting through the egress gateway will preferably go through an egress node located in the same zone as the workload. If it's not possible, then it will fall back to an egress node in another zone. So let's apply this now. What happens when we look at the status of the gateway policy, we see that now there is a field called active gateway IPs by AZ, which matches the zones for the topology to internal IPs of the nodes where the traffic needs to be sent to exit the cluster. Now let's look at our pod. We have an X-Wing pod, and this pod is currently running on the kind worker node. And this kind worker node is in the east zone. So we're going to use kind worker 3 to exit. Let's look at the IP address associated. This is 172.18.0.42. This is the IP address that is on the net 0 interface. Don't mind the down status. This is because I'm using kind and playing a little bit with the interfaces in Docker. But on a real VM, you should have an interface that is actually up. Now, if I make request here coming from the X-Wing and going to an echo server I have that is outside of the cluster, then it goes through the gateway API and it goes through the 172.18.0.42 address, which is the egress gateway associated to the same zone, to the east zone. So we see that we have this affinity in place. Now, what about resilience? What if the east egress gateway actually falls? We're going to pose the container for this to simulate the egress gateway VM actually not being available. And now if we make requests again, we see that the requests are still reaching out, but this time they go through the west zone because we don't have an egress node in the east zone anymore. What if we make the egress node for the east zone available again? Right away, our traffic is going to go through the east node again. So we see that you now have a possibility to not only route traffic through a known IP address or through several known IP addresses doing load balancing on the egress node, but you can even have affinity to make sure to optimize latency by going through the same topology-aware affinity using these topology labels in Kubernetes, and that even then, if one of the nodes in the same availability zones actually fails, it's still going to go through another node, so you have the guarantee of resilience of your system. That's it for today. You can test this feature in the updated egress gateway lab that we have on isovalent.com/labs. Have fun. Have a good day.